Morning class. So today we're looking at functions part 2. So in the next two videos we're just going to look at determining the equation of graphs. At this point we have completed analytical geometry and you guys should be okay with calculating the equation of straight line. Okay. So I gave you up the sums yesterday and as promised we're going to do the recording of this part today. Let's call this part basically lesson 1 on this. So the question says determine the equation of this parabola. We know that the standard form of a parabola will be in the form of y is equal to h squared plus q. Now normally that equation is given to you. Okay? Alright, so what are we given here? We are given two x-intercepts. Whenever we are given two x-intercepts, we follow the formula y is equal to a into x minus x1, x minus x2. So we go y is equal to a into x. So if this is x1, so it will be minus 4. You can have minus 4 becomes plus 4 and x minus not so. So what still needs to be solved here? A. So what we do is we substitute the pointed line on this graph other than the points that we used. It's going to be 1 and 15. That's the x and the y. 15 is equal to a into 1 plus 4, 1 minus 4. Of course, 1 plus 4 is 5. So it's a into 5 and minus 3. What's a? 5 times minus 3 times a? Negative 15. So divide by negative 15 both sides. So a is equal to negative 1. So it's my equation. Y is equal to negative into x minus 4, x plus 4, x minus plus 4, x minus 4. Now, is it in that form of the original graph equation given? No, so we must multiply the story out, not so. So we say y equals, multiply the loss plus the loss, negative x squared minus 16. Which will give us negative x squared. Okay, guys, understand people? Is there any confusion here? Look at the next one. Again, we have two x-intercepts. The standard form that we normally wanted in is y is equal to x squared plus q. Okay. But since we have x-intercepts, what do we do? Y is equal to a into x minus x1, x minus x2. Okay. Where x1 and x2 are x-intercepts. This is x1, x2. So you got y is equal to a into x minus 2 becomes plus 2 and x minus 2. So what still needs to be solved here? A. So we'll substitute the pointers lying on this graph, which is 0 and minus 8. So x and a 1. So negative 8 is equal to a into 0 plus 2, 0 minus 2. So it will be a into 2 into negative 2, negative 8. How do we get a on its own? Divide by negative 4 both sides. So a is equal to 2. So y is equal to 2 into x plus 2, x minus 2. Get rid of the brackets. I get x squared minus 4, which now gives me 2x squared minus. Okay. Any confusion here? No? So I gave you three sums where all three has x-intercepts. The three sums I gave you, does all three have x-intercepts? Okay, so I must do at least one where it's different. So yesterday we did three where it was different. No?
Yes.
I only did one where you had the x-intercept.
Yes.
No? And today is completely opposite. Okay, so let's go again. So we have y is equal to ax squared plus q. That's the standard form they wanted in. So because you are given x-intercepts, what we do? Y is equal to a into x minus x1, x minus x2. If this is x1 and this is x2, so y is equal to a into x plus 5, x minus 5. What do you need to do? You need to solve for a. So we'll substitute the pointers lying on this graph, which is 0 and 25. That's the x and the y. So 25 is equal to a into 0 plus 5, 0 minus 5. So it will give you a into 5 and negative 5. So it is 5 times negative 25, negative 5, negative 2. Give me the answer then. So a is equal to negative 1. So y is equal to negative 1 into x plus 5, x minus 5. Simplify that. Gives you negative into x squared minus 25. Get rid of the brackets on the outside. So negative x squared plus. Okay. So before we go into hyperbola graphs, let's do one where the intercepts are not given. The x-intercepts are not given. Did I do number 2 yesterday? Did I do this one? Did I do that one yesterday? Just for the sake of the video, I'm going to do it again. Because we're looking at the form where it's not given. Okay, not given the x-intercept. So if that is given, people, we're going to work in the form of y is equal to x squared plus q. Normally that's the standard form of the equation. Where do we start? We substitute the point is lying on the axis. So we'll substitute 0 and negative 1. Okay. 0 and negative 1. There's an x and a 1. So we say negative 1 is equal to a into 0 squared plus q. 0 times a 0. Q is a negative 1. My equation now reads y is equal to ax squared minus 1. So what do we still need to solve? We'll find a point on this line which you haven't used yet, which is 1 and negative 2. Remembering there's an x and a 1. So negative 2 is equal to a into 1 squared minus 1. To get over becomes, so negative 2 plus 1. So a is minus 1. Therefore y is equal to negative x squared minus 1. You can, and then, but remember the standard form. If you're going to take out negative here, it's going to read y is equal to negative x squared plus 1. But that standard form has no brackets in it. You understand? So we wouldn't go that far. People, any questions here? Any confusion? No? I think that is fairly simple. So I'll take this off. The full lessons can be found in the description box below. Okay. Then yesterday we've done hyperbolas as well, and this is the sums I gave you for homework, correct? This was the first one of the four. No? Okay. So the standard form of an hyperbolic graph is y is equal to k over x plus q. Y is equal to, it could be a over x plus b. Or it could have been y is equal to p over x plus m, whatever. No? How do we know it's a hyperbolic graph? The unknown is in your denominator, in your denominator. Can you see that? So when we start, we know that the horizontal asymptote is y is equal to 2. So that means to say that q is equal to negative 2. Not so much the horizontal asymptote. It's always this value here. So we have y is equal to k over x minus 2. So what do we still need to solve here? K. So we need to substitute the point on the graph we haven't used yet before, which is 2 and minus 6. So they substitute 2 and minus 6. It's a x and a 1. So negative 6 equal to k over 2 minus 2. So what do we do? Take negative 2 over. So negative 6 plus 2, negative 4 k over 2. Now what do we do? First multiply. So negative 4 times 2 is negative 8 is equal to. Therefore, what's my equation? Y is equal to negative 8 over x. Is there any confusion there? Okay. Let's carry on. Let's look at the next one. What do you notice here? The asymptote. You don't see the asymptote. The asymptote is not indicated. But we know that which axis is your asymptote. X and Y is your asymptote. That's so, but the horizontal asymptote is what we know, what we're interested in. The standard form is y is equal to k over x plus q. We know that the q value is 0. So y is equal to k over x. So what do I do now? What are you going to substitute? So you're going to substitute negative 3 and 5. There's the x and the y. So we have 5 is equal to k over negative 3. There's natural over 1, you cross multiply. 1 times k is k, 5 times negative 3, negative 15. So what's my equation? Y is equal to negative 15 over. Okay. Fairly simple, no? The next question. Here we have a horizontal asymptote of 3 and it's going through 1 and negative 2. So we will follow the formula y is equal to k over x plus q. Alright. The horizontal asymptote is 3, so q is equal to 3. So y is equal to k over x plus 3. What do we do now? We substitute the point is lying on this curve, which is 1 and negative 2. And being an x and a, so negative 2 is equal to k over 1 plus 3. So k is equal to negative 1. So y is equal to negative 5 over x. Easy, no? Yes? One sum. One sum per time. Maximum. Sometimes none. For this question, 3 or 4 marks. For parabolas, it's 4 marks. Okay, let's look at this one here. Again, the standard form of this parabola will be in the form of y equals k over x plus q. Now here we don't have the value for q. However, we know that the axis of symmetry, so y-intercept, which is 1, is also the equation of this asymptote, which is y is equal to 1. So therefore q is equal to, so you got y is equal to k over x plus 1. Now we're going to substitute the point that's lying on this curve, which is 0, negative 4 and 0. It's an x and a y. So 0 is equal to k over negative 4 plus 1. So what do we do now? So you get on that side, so it's going to be k over 4 equals 1. Yes, k is equal to 4, yes. So therefore, y is equal to 4 over x. Okay, is there any confusion there, people? Okay. So that basically brings us to the end of determining the equation of hyperbolas and parabolas. Okay, so now we're going to look at determining the equations of the exponential curve. As therefore for that, it's dealing with straight line graphs. At this point, you should have known all about straight line. Okay, determining the equation of straight line. Okay, so we have done it in analytical geometry already. One example. To determine the equation of a straight line. In C. You see the problem? Okay, so let's look at it. This is the equation of straight line graphs. We are given this here. So that is 3. That is negative 1 and negative 4 and negative 1. The question says, determine the equation of the following line in the form of f of x equals ax plus q. Now we know it's the same as saying y is equal to mx plus c. Okay. Well, how do you calculate m? So gradient. It's y2 minus y1 over x2 minus x1. So the points are negative 4 and negative 1 and 0 and 3. If that's x1, that will be y1, x2, y2. So we say 3 minus 1 over 0 minus 4. Now you can do that. You know it's going to be 4 over 4, which is 1. So we didn't know that. We use a calculator. 3 minus 4. Sorry, minus 1 over 0 minus negative 4. Gives you 1. Okay. So my equation now reads y is equal to 1x plus c. Now we know c is also your y-intercept. Not so. You want your y-intercept here? 3. So c is 3. But say we didn't know that. So you can substitute any of the 2 points. Substitute negative 4 and negative 1. That's the x and the y. So negative 1 is equal to 1 into negative 4 plus c. Negative 4 taken over the equal sign becomes positive 4. Negative 1 plus 4 is 3. So the equation y is equal to x plus 3. You guys understand? Do another one. This is 3, yes? Yes? Sorry? Scroll down, yes? And then? Okay. Next one again, we must determine the equation of the standard, in the standard form of y is equal to mx plus c. Where do we start? Gradient. How do we calculate the gradient? Change in y by change in x. The coordinates are -3 and 0 and 0 and 6. So we make that x to y2. So it's going to be 0 minus 6 over -3 minus 0, which is negative. It's positive 2. -6 over -3. Okay, so what's my equation? Y is equal to 2x plus c. So what do I do now? I substitute one of the points. Or we know that c will be 6. So therefore your equation is y is equal to 2x. Okay. Finish. Okay. She's taking pictures there so I can move a bit faster. If you need to, you can pause the video at this point and then you can just determine the equation of the next graph before watching the solution. Okay. Also, the full lessons can be found in the description box. Okay. Alright, so let's look at this one here. What do we notice here? We have coordinates given. It's not on your axis. So the standard form of a straight line is in the form of y is equal to mx plus c. So where do we start? Start with the gradient. Okay. Which is? Change in y to change in x. So if you make this x1, that will be y1, x2, y2. Let's go with it. -1 minus 4 over -3 minus 2. Which is -5 over -5, which is? So y is equal to 1x plus c. Now you see the c is your y-intercept. Not so, if we know the y-intercept value, although it looks like a 3, we can't just assume. Okay? So what do we do? We substitute one of the 2 points. I'm going with 2 and 4. That being an x and a y. So I say 4 is equal to 1 times 2 plus c. So c is 2. So you see I was even wrong there. So y is equal to x plus. Will you guys understand? There's another one. Will you guys understand? Okay. So now we're going to look at exponential graphs quickly. Okay. So let's pause here quickly. Right. So let's look at this quickly. This is your exponential graphs. The question says, find the equation of the exponential graph. Okay, so let's look at the first one. You see, importantly here that the equation is given. Okay, let's call this A for now. So the graph is given as f of x equal to a times 2 to the x plus q. Y is equal to, or f of x equal to a times 2 to the x plus q. Okay. So, people, what do we know from this offset, from the beginning? What do we know? We know the value of q. So, why do we know the value of q? That's your asymptote, your horizontal asymptote. So, your q value is equal to -8. So, So my equation now reads f of x is equal to 8 times 2 to the x minus 8. Okay. So what must still be solved in this question? A. Not so. Do we have a point that's lying on the curve? Other than, yes. So we're going to substitute 0 and negative 4. That's a x and a y. You all agree with that? What's my equation now? Negative 4 is equal to 8 times 2 to the 0 minus 8. What's 2 to the 0? 1. So negative 4 plus 8 is 4. So what's my equation? F of x is equal to 4 times 2 to the x. Will you guys understand? Let's do it again. You say yes? Right. So let's do it again. Now the questions, you see you're talking while I'm talking. Now that is why I don't understand. So we got given the exponential function, okay? Where f of x equal to a times 2 to the x plus q. And we said, what is q? Q is your horizontal asymptote. We have the horizontal asymptote here? Yes. So q is equal to negative 8. My equation is f of x is equal to a times 2 to the x minus. So what do we need to solve now? A. Okay. Has one unknown, so I need 1 point on this curve, which I do have, which is 0 and 4. Negative 4. So substitute 0, negative 4. There's an x and a y. So negative 4 is equal to a times 2 to the minus 8. Anything to the power 0 is 1. So negative 4 plus 8 is 4. So as my equation, f of x is now equal to 4 times 2 to the x. Okay. Okay, let's go to the next one. Example B. Determine the value of A and Q if the equation is given by the graph of g of x equal to negative b to the x plus q. Right, where can we start here? What do we have? We have our horizontal asymptote. So q is equal to 3, which is that thing. My equation now is g of x is equal to minus b to the x plus. So what still needs to be solved here? B. Not so. Still need to solve for b. Right, do we have a point that's lying on this graph other than what we use now? Yes. 0 and negative 1. And negative 1 and 0, not so. So you're going to substitute negative 1 and 0. Remembering that's x and a. So what do we have now? 0 is equal to negative b to negative 1 plus. So what do we do now? Take a b over. The b now becomes positive. The b to negative 1 is equal to 3. Now what? 1 over b is equal to 3 over. So I can cross multiply. 3b is equal to 1, so b is equal to a third. So therefore, f of x is equal to, yes, g of x is equal to negative, open brackets, 1 over 3 raised to the x plus 3. Okay? Yeah, any confusion? You guys understand, huh? Okay, and the last one of this type. Determine the equation of the given graph in the form of y equals a times b to the x plus q. Where can we start here? Horizontal axis. Q is going to be what? Negative a third, as you can see here. So y is equal to a times b to the x minus 3, a third. Now what? How many unknowns do we need to solve? 2, which is a and b. So how many points do I need? 2. Piece of information of 2 points at the wasn't used yet. We have 2 and 1. Where's the other point? 0. Why 0 and 0? Going through the origin. Can you see that? Alright. You understanding yourself? For once? Okay, nice. I'm glad. Right, so we'll substitute the origin, which is 0 and 0. Remembering that's x and a. So what will this be? 0 is equal to a times b to the 0 minus a third. What? Oh, 0. Alright, now what? B to the 0 is 1. That means you say a is equal to a third. A third is equal to a. So what's my equation now? Y equals a third times b to the x. Okay. So what must all be solved here? There we go. Substitute. 2 and 1. Remembering that's x and a. So 1 is equal to a third b squared minus a third. Now, the third over the equal sign, yes? Then becomes 1 and a third, yes? Which is 4 over 3 is equal to 1 over 3 b squared. Divide by 1 over 3, yes, both sides. So b squared is equal to? Should be 4. So 4 over 3 divided by 1 over 3, I say should be 4. It's 4. Now what? Square root. What must I not forget? Plus minus.
So there must be a 4 last week.
Yes, I'm thinking of the answer. Okay, so the square root of 4 is 2. Plus minus 2. But remember that b has to be positive. Not so. Therefore, B is equal to 2. Yes, Michael, your hands up. If you use 2 and 1 first, then you're going to go into simultaneous equation. There would be nothing wrong if you had gone with 2 and 1 first. But you wouldn't have been able to solve it at that point, because if you had gone with 2 and 1 first, remember that's the x and the y, it's at this point. So it's going to be 1 is equal to ab squared minus a third. So that over becomes 4 over 3 equals ab squared. And that's equation 1. Then when you go with 0 and 0, then you'll see that your a is 3. Then you Then you substitute the third in there and you'll solve for b again. Yeah. So it'll be always easier to substitute before you just line on your answers first. Yes, Michael. You don't have to say. Okay, anything else? Sorry? Where's the plus and minus? Yeah, 4. Yeah. Is it 4 here? Yeah, whenever you're introducing an even, the root must be plus minus. Okay. But because B, there's a prerequisite on B, or condition on B, that B has to be positive. This here. That always has to be positive. Otherwise, you're not going to get an exponential graph. The graph will toggle, or it will just move up and down, oscillate. No? So, what's going to happen is that has to be positive. Otherwise, this curve is not going to look like this. Okay, guys, understand? All right, anything else? So with that, you should be able to do exercise 11. Okay. There are 6 sums. I would like you guys to do all 6. Okay. Let's stop the video at this point.